Alright, before we get into content, got some announcements. I don't know what to call it. A spiel to do. So there's been some misconceptions and some stress and confusion. I just want to try to clarify some things. So let's take a time out and kind of revisit some of the things I talked about on day one, and just talk about them now that we have some context to talk about them in. You've experienced the course for 3 weeks, and those things are going to be a little more meaningful now. So let's revisit a few of those things and clear up some misconceptions. One, I may have started this rumor, but I have a lot of students panicking in the course about making too many submissions on AutoLab. In all 3 lectures, and especially the 3 p.m. that just ended, I got really dramatic in the 3 p.m. and said, if you have more than 50 submissions, you don't know what you're doing, and I went a little overboard with it. So let me try to squash these rumors and get this making more sense. So if you have a lot of submissions for a particular question, that's not just, a lot of submissions, therefore bad. It really depends on why you're making a lot of submissions. So if you're making a lot of submissions, and the behavior that I don't want to see, that I'll be looking for, is if you're using AutoLab as your tester, and in some cases using AutoLab as your compiler. That's what I really don't want to see. If you're submitting code that doesn't compile in 1.16, you got to refactor your strategy. You got to have a different approach there. So that's the kind of stuff I'm looking for. If you're just clearly using AutoLab in general as a guess and check tool, and just kind of abusing the system and abusing the feedback, that's what I don't want to see. So if you have these incremental changes, you're just changing a line, submitting, changing a line, submitting, changing a line, submitting, that's no good. But if you have, say, 100 submissions and you had pretty good code early on, but then there was just some small thing that was frustrating you, you had to make a bunch of submissions to try to figure out what was going on. For example, on Friday's lecture question, I had a capital L in flashlight. It drives me nuts I made that mistake. Flashlight should be one word, so that should be a lowercase l. And maybe you had it as a lowercase l, and you made a whole bunch of submissions trying to figure out what was going on. But really, all you had wrong was I had some character that shouldn't have been capitalized in the question, so you submit it with a lowercase l, and you're driving yourself nuts making a bunch of submissions. That is significantly different than somebody using AutoLab as a guess and check. And I can see things like that. I can check like your 5th or so submission, and if your 5th submission, I'm just saying 5th, but if one of your first submissions was pretty close to your 100th submission, and you're just trying to fix that, find that one little thing, or maybe I had some strange wording in the lecture question, and you interpreted it a slightly different way than I intended it to be interpreted as. That's one comes to mind. I don't know if the students in this section or not, but I was looking through someone's battery submission, and replace batteries had a check where if the battery from the parameter, if that parameter battery that you're replacing with had a charge of 0, they wouldn't replace the battery. So they're saying, why would you call replace battery with a dead battery? You're not allowed to do that. That was nowhere in the spec, so it's not right according to the lecture question, but it's not crazy. Like, it's not something that would discount your understanding of references, which is what I'm getting at with that lecture question. So if I see something like that, that's a lot different than somebody using AutoLab as a guess and check. And that particular student had a lot of submissions. I did that, I was looking through their submissions, and yeah, they nailed it pretty early. They had the question, all the concepts I was testing, they understood really early on. They had a lot of submissions because of that. They were testing to make sure that the battery wasn't replaced if it was no charge, and of course, failing my correct solution. And once they have that in their code, that's not something they're just gonna find all of a sudden being like, oh, replace battery, I'll just always replace it. So that wouldn't count against them. And with late submissions, the complete, getting that bit to flip for complete from 0 to 1 is quite meaningless. And I know it's, in most courses that would mean your score and your points, And I saw there's the poll on Piazza that wants more lecture questions or some lecture questions with double points, and there's some suggestions going out around there, different things to do. Getting credit after the deadlines and stuff. I just want to clarify, there's no such thing as score or points or anything with these lecture questions. The complete is just one bit that flips once AutoLab has no more feedback to offer. You've satisfied everything the auto grader has for you, and it just means there's no reason to submit anymore. It doesn't necessarily mean you're done with the question, and it doesn't really mean that if you don't get that bit to flip to 1 that you're not done with the question, if that wording makes sense. So let me clarify that a little more, and in the context of late submissions. If you make a late submission, you get the score of 0 in AutoLab, or not score, I just made the whole thing that's not score. The complete bit flips to 0 no matter what you submit. But when I'm reviewing these 3 bullet points and looking at your submissions to see if you meet these 3, if you did complete these 3 bullet points, if you can do these 3 things, and you submitted 1 minute after the deadline and AutoLab says 0, or 1 minute before the deadline and AutoLab says 1, why would that difference matter to me? That is not going to make a difference in my decision when I'm deciding, did you complete these 3 bullet points? Can you do these 3 things? Question?
So you're saying, like, if somebody's been doing it the entire time and then just submits the correct solutions, say, like, the day that everything's due, you're okay with that because they've learned the objective?
On the surface, yeah. Yeah, I'm fine with that. So the deadlines are what I call soft deadlines in this course. You can keep submitting after the fact. AutoLab shows a 0, but that doesn't have any meaning. The deadlines are, I lost my place, hold on. The deadlines are what I call soft deadlines. That's me saying, this is where I expect you to be at this point. At this point in the class, at this time, midnight tomorrow, I expect you to be able to do the lecture question for today. That's more of your warning of, if you can't do that problem by that time, it means you're falling behind in the class and you need to do some extra work to get caught up. It doesn't mean you can no longer get credit for this lecture question. It's not like that. It's a different kind of deadline than you're used to in other classes. It just means, hey, you gotta catch up, you're falling behind, because most of the content in this class, you know by now, it goes fast and it all builds on itself. If you don't understand today's lecture content, by Wednesday's lecture, you have no chance of understanding Wednesday's lecture, because we're going to build on what we talk about today. And that's the idea of the lecture questions. Before the next lecture comes, I need you to practice this stuff, because you're just going to waste your time on the next lecture because you have no idea what's going on. It has nothing to do with your completion of the learning objectives per se. You know, if they're all late and there's clearly some really poor study habits going on, and that's affecting my ability to decide if you've completed these 3 bullet points. You know, there can be situations like that, but more so it's me saying, hey, this is where I expect you to be at this point in time. It's not a hard deadline. So if you have 6 lecture questions complete, but 2 or 3 of them were after the deadline, I don't really care that much. I'm gonna look at the scores and see that you did complete those other ones after the deadline, and that's significantly better than not completing them at all. I've said that before. I don't feel like it's really that word's gotten out there as much as I want it to be, because there's been a lot of panic on Piazza specifically. But if you complete them after the deadline, way different than if you don't complete them at all. If you don't complete a lecture question at all, you know, that's pretty bad. Actually, not necessarily, and I'll get into that too. So what I recommend is putting yourself in my shoes. On Friday this week, or starting Friday at 10 p.m., after the last lab section is over, I'm going to have all the information for this learning objective for the first round of this learning objective. So I'm going to have 6 lecture questions, the lab activity, and the lab interview. And I'm faced faced with this challenge. I have 379 students, and I have to decide who completed this learning objective, and who did not. So you can kind of guess where, like how I can make those decisions. And I'm not going to look at every single student's submissions at a very deep level, obviously, because then you wouldn't get your grades until probably next year. But what I'll do is pull up all of the information, look at anybody who is an obvious yes. If you completed 6 lecture questions, maybe some of them, maybe 2 or 3 of them were late, I don't care. You completed 6 lecture questions before I start reviewing this stuff next Friday, or this Friday. Your lab activity looks good. You got tons of information about the stack and heap for me, and you clearly know how that program execution works. And the TA interview, no red flags. Seems like you know what you're talking about during that interview. Those are all easy yeses. I'm hoping that's going to be, I don't know where my estimates are going to land, but I'm hoping that's at least half of the class. I can just say, you all completed program execution, done, complete. Then there's going to be a section of the class. I hope this section isn't too big, but there's going to be the section that are the easy no's. Okay, you didn't even do half the lecture questions, or you didn't show up to lab, or your lab activity, you missed 2 lecture questions, and your lab activity is just like, yeah, stack and heap are really cool things. And no details or anything, and the TA interview went maybe okay, but not great. Those are all easy no's. If you didn't even bother to do the lecture questions, even after the deadline, even with, like you said, if all 6 are late, you know, it's kind of whatever. If you don't even do like 3 of them, if you just completely skip 3 of them, never submit them. Come on, give me something to work with. You got to give me something. So those are easy no's. It's everything in the middle. That's when all these discussions that we have are going to start coming in. Okay, I don't have enough information to make a quick decision, either yes or no. Let me start looking deeper. And that's why I'm going to look at these 3 bullet points individually. I want to see that you've completed all 3 of these. So the feedback I give to you might be, hey, you're good on the first 2, but I don't quite have enough information on this 3rd one. I just need to see something more from you on that 3rd one. So with these decisions, that's what I'm going to start looking at: number of submissions, how you progress through the submissions, anything I can get my hands on, any information I can get to help make that decision better. If you're in the easy yes category, I'm probably not even going to look at your number of submissions. It's not even something that I'll consider, because I already know you understand the material. I don't need any more evidence at that point. But those middling students, if you missed a lecture question or 2, you know, I just need more information. That's what I'm going to start looking wherever I can to find information to see if you completed these. And I'm going to make these decisions as a rational human being. I'm going to look at all the evidence and try to decide, did you complete these 3 things? So here's my job. What I'm making my job is, if you do complete these 3 objectives, if you know in your heart that you can do these 3 things, you shouldn't have any stress. You shouldn't have to worry. My job is to figure that out. If you actually do complete these 3 things, you can do these 3 things, I got to figure that out. And I got to do that in a way that's not going to cause you too much stress, assuming that you're providing the evidence to me. Obviously, if you can do these 3 things and you don't submit any lecture questions, you know, I can't do anything with that. But that's my job, is to look at this as a rational human being. Can you complete it? So let me give you an example. Automated testing, this first bullet point. We had 5 lecture questions with testing on them. And maybe you don't do so good. Maybe 3 or 4 of those you didn't do all the testing for. Or actually, let me start with this scenario. One of them, maybe the battery one, you couldn't get one of my incorrect solutions to fail. But I look at your tests, they look pretty good, and the other 4 lecture questions where I had to write tests are looking good. You completed those and everything looks good. Well, at that point, I'm probably going to say you understand how to do unit testing. If you didn't do any of those questions, maybe you just did one of them. Any is a little too strong. Maybe you did one of them, maybe you got like last Wednesday's, which was fairly complicated, checking the references with equal. But you didn't get any of the other testing lecture questions. Maybe you got the completion part, the functionality, but not the testing parts. But by Friday, you submit Physics Engine and you get all 3 of those testing objectives. I'd say you can do unit testing at that point. I can check you off on that one. It's not just, here are your couple opportunities. Anywhere where you can show me that you've completed, that you can do these bullet points, I can use that as evidence, and we can go from there and start checking off these boxes. Anywhere that you show me you can do things. To that end, this third bullet point, I keep saying that I only had the lab activity and the TA interview to test this third bullet point because I can't test you on the lecture questions. It's not necessarily true because when we talk about immutability, when we talk about linked lists, when we talk about trees, we're going to talk about the stack and heap again. So if we don't complete that objective, or any of these objectives, during these 2 weeks of lecture and the one lab, you're still going to have more opportunities throughout the course to complete this objective. And I said this on day one, but I kind of made it sound like there will be additional assignments that you can work on, or I'll throw extra lecture questions out there, stuff like that. That's not necessarily true. There's just going to be other opportunities where we're building this material. We're not just going to throw away program execution once we move on. We're still going to use this material and build on it elsewhere in the course. So if you can show me how a linked list is represented on the heap, and how all the references map to each other, I mean, I can go back and check this bullet point off. So maybe your feedback for this one is, you got the first 2 bullet points, but not so sure on your understanding of stack and heap. Your lab activity was kind of lacking in detail, and your TA interview, you said objects go on the stack or something. I'll be like, I'm not convinced. Then we get to immutability, and we talk about how linked lists, how strings are immutable, they're on the heap, but how we pretended they were on the stack before, this is what we meant. And you really show me that you understand how those string references work. Yeah, I can go back and say, yep, I'm satisfied, you know that one, check. Complete, learning objective complete. So you will have more opportunities. It's not necessarily more assignments, it's just other places in the course where we're using the same concepts and the same ideas. I can look at that and just think, again, as a rational human being, hey, you did all this testing over here. I don't really care so much that you didn't do this testing over here. During the week when I was talking about testing, you didn't understand it the day after you first heard what a unit test was. Not too concerned. Over here, later on in the course, you show me that you really understand unit testing. We're good. That's great. Yes?
Will we be able to see, like, if we actually ticked off those boxes or not, like, anywhere?
Yes, so I'm hoping to get this by early next week, your feedback for these objectives, for the program execution objective. It's a really important thing. I want to get that out as fast as I can. I'll probably end up working the weekend quite a bit to get that out to you. I won't make any decisions until Friday, 10 p.m. That's when I'm going to start pulling the data, because that's the last lab. So the Monday labs, you got to wait for quite a while. But after that, either you completed the objective and your feedback is fantastic job, or you didn't complete the objective, and I'll explain why. I'll explain which bullet points you got, which ones you didn't, and at least what bullet points you got and what you didn't, and possibly some more detailed feedback, depending on how much I looked into each case. Like the easy no's, I probably won't have much feedback, but any of those middling cases that almost got it complete, probably get some better feedback. Yes?
I already had and I did lab activity. It didn't, for Google Forms, when you submit, it gives you an email of like your responses. It didn't do that for.
It doesn't always. I turned that off for this one.
Okay, yeah, I'm just checking.
I thought I made it optional. Maybe I turned it off completely. But that's an option on the form that I can do. Why would I turn it off completely though? I'll have to check that. I meant to give the
Yeah, the
option.
other one did. The other one sent a response back.
Yeah, 'cause some of them I do have automatically. I don't give you the option; it just sends you an email. But that doesn't mean I didn't get your submission.
Okay, let's check.
The application objectives, on the other hand, those are different. Those are hard deadlines for the homework, so you got to have the homework done by then. You verify it in lab the next week. The one thing I want to say about this, if you complete the program, the primary objective, I might have said this in this lecture already, worth repeating. If you completed the primary objective, but not all the testing objectives, I'm not too concerned. The idea of the application objective is that you can take the learning objective and apply it to a real world problem, solve a real world problem. And then I have the 3 testing objectives to give you a little scaffolding to help you work towards that primary objective without just throwing you in the deep end. If you don't need that scaffolding completely, you can get that primary objective without all the scaffolding. Well, that little bit of hand holding, then by all means do it. There may possibly be cases where I can reach out and be like, hey, you didn't really complete this, but it won't be a surprise 0. If you completed the primary objective, you're probably just going to get completion. You're probably going to get credit for it. But if you don't, what I'll do is reach out to you and say, hey, there's this issue. Can you remedy this? And then you can get your credit. It'll be just some extra thing that you'll have to do. I don't know what scenario I'll do that. I might not even do that for anyone. I might just say primary objective and the verification lab, of course. You'll have a quiz about the homework assignment in the lab, the following lab. If that goes well and you got the primary objective, you're going to be most likely good. But the deadlines are hard deadlines for that. The learning objectives, that's where I have this very harsh stance. It seems harsh on the surface at the very least, where it's 5 of these, complete all 5 or fail. That's where I'm giving you all kinds of opportunities. You can always prove to me that you completed ultimately 15 bullet points by the end of the semester. Check all those bullet points off. I'm going to give you lots of opportunities. The last learning objective shuts off with 3 weeks left of lecture, and the project is going to be during those last 3 weeks. The project is a lot of application of that 5th learning objective, that event-based architectures. So we have time. I can give you many opportunities to even get that 5th one. It's all designed to give you lots of opportunities to show me that you've completed those 15 bullet points. So there's a lot of room there. For the application objectives, that's where you're working towards your A. You got to earn that. It's going to be a little more strict. Okay. Any questions on all that? Hopefully I cleared up some misconceptions that have been stressing people out. Let's move on to the next one. So we got a new set of bullet points. We're going to talk about our first of 2 programming paradigms. And these are going to give us ways to organize our programs in a way that helps us in the future, specifically helping us expand our programs. So object-oriented programming specifically, we want to be able to reuse code. We have this idea of encapsulation. We want to take a piece of code and then use it in a lot of different applications by isolating that piece of functionality. We have these ideas of organizing our code in objects and classes and having them interact with each other to be able to organize that large project. Instead of having one big main method like we might be tempted to do, let's break that code up into objects, have those objects interact with each other, and have ways to make those objects easier to write, and most importantly, in my opinion anyway, easier to expand. If we want to add new features to our program after we write it, how do we add those features in a way that doesn't make our lives completely miserable? How do we have our code base set up to make the code easily expandable? So to that end, we're going to see a few topics. Today we're going to talk about inheritance. Wednesday we're going to talk about polymorphism. Friday is going to be an application of polymorphism, working with JSON in a strongly typed language like Scala. And then all of next week is going to be this last bullet point, which does depend on inheritance and polymorphism. If you get this last bullet point, I probably don't even have to think about the other 2. It'll be implicit. But all next week we're going to talk about what's called the state design pattern. This is going to allow us to change the behavior of a program based on the types of objects, which should be by Wednesday. I'll get the next round of homeworks out. I wanted to get them today, but I was working on lab late last night. But the homeworks are going to be write programs, solving a real-world problem without using control flow. No conditionals, no loops. So how do we write software that doesn't use either of those 2 concepts? They're pretty fundamental concepts. So usually we want to say, if condition, execute this code conditionally. Else do this other thing, but we want to execute code conditionally. Once that's taken away, we're going to see how we can write programs by having the behavior change based on the type of an object So go to a state variable, say, hey, reference to an object, call your method, and have that method define what's going to happen. And then I can change that object that's stored in the state variable, call that method again, and have it have different behavior based on the type of the object that's stored in that state variable and the current state of the object stored in that state variable. We're going to, just like that sentence, we're going to use the word state so much it's going to lose all meaning. But we're going to talk about that in the state pattern. So that's what we're building up to. Next week, how are we going to write those programs without conditionals, without control flow? So to that end, let's get started with inheritance. This is where it all starts. So the lecture question today is going to be functionally identical to the lecture question on Friday. But when you wrote that lecture question on Friday, you notice that a lot of the functionality was very similar between Boombox and Flashlight. And I have to mention this again. I'm so embarrassed about this. This L should have been lowercase. Flashlight, I'm so sorry if that caused a lot of frustration for anyone out there. Flashlight is one word. That should be a lowercase L. I left the typo in with this question. I left the typo in just for consistency. But yeah, that should have been a lowercase L for because that Flashlight is one word. But we're going to write the same functionality, but those Boombox and Flashlight classes had a lot in common, a lot of common functionality. And even one of the methods was completely cut and paste identical between Boombox and Flashlight. So it kind of seems silly that we're duplicating all this code, and we're going to fix that today. So we're going to fix that by creating what we call an abstract class named electronic that's going to hold all of the common functionality between these two classes, and then only the functionality that's different between the two is going to be in the Boombox and Flashlight classes. So we're going to effectively factor out all of the common functionality of these two classes into one abstract class that they'll both inherit, and then implement only the different functionality, what's left after the factoring, in Boombox and Flashlight. So we don't want to repeat any code twice. We just want to have every piece of code we write, every piece of functionality we implement to only exist once in our code. We're going to do that with some inheritance. So this diagram, we've seen this before, it's in some of the documentation I linked on the course website. And we want to make sense of this chart, and I'll pull this up again later in the lecture to make a little more sense of that after we know what inheritance is. So let's work on a problem, and I want to build some core functionality to a game that admittedly we probably won't implement the full thing, but just as an example, we want some core functionality that we'll build for a simple dodgeball game. We have players that can move around in a 3D space. They can interact with balls, they can throw them at each other, and if a ball hits a player, they're going to lose some health, and we can collect health potions to regain some of that health back. So to build this game, we need 3 different objects: player, ball, and health potion, the 3 nouns we talked about in that previous slide. And how are we going to implement those? So let's do a quick review of objects and classes. Objects and classes came and went real quick 2 Fridays ago. I said, here's objects and classes. You know these now, right? We're going to use them. So let's do a little bit of review, because we need to understand these objects and classes so we can move before we talk about inheritance. So a little quick review on these things. So an object is how we can package state and behavior. We have all these state variables and methods for the behavior which depend on the current state of the object. And here our methods, we're going to pass the calling reference of this player to those methods. These methods take a player reference as input, as their parameter. So I'm going to pass this, which this contains a reference to the calling object. So this is a reference to this player object. I'm going to pass it there. And then ball and potion, they're going to access the state of the player to have their functionality. So we have all these state variables and behavior for our object. Ball, very similar. We have location, dimension, velocity, so these things can exist in our world, in this simulation of a world in our game, and also move around in that world. For balls specifically, we'll have some mass. And some method, when we call use method from the previous slide, we get that player reference, which was in this on the other slide. And we're just going to do something with it. We're going to set that ball's velocity in the direction that the player is facing, and just throw that ball in that direction. Health potion, similar, except it has volume, so we want to know how big is this health potion, how much potion does it have left, and the functionality, when a player uses it, replenish some of their health and make sure we don't go over their max health. We don't want to exceed that limit. So we have these 3 objects in our game. But as this is a super boring game. We create these as objects, so we can only have 1 player, we can only have 1 ball, we can only have 1 health potion. Because we created these as objects. This is not very interesting. And this is why we use classes. So we created these as classes, and now we can have multiple objects of these types. Now I want multiple players. I'm going to use the player class to create multiple player objects, and I can have a multiplayer game. I'm going to create multiple balls and health potions. I can have a lot of items scattered throughout the game world, and we can start actually playing the game as it's intended, instead of just having single objects of these types. So now we refactor our code. We take those objects, turn them into classes, and any state that we want the caller to be able to initialize, we move that to the constructor. So we move most of the player's state to the constructor and let the caller initialize all of these values. Initialize where this is, how big it is, all these factors. We don't have to move all those up to the constructor, but whatever you want the caller to initialize, put it in the constructor. And then health, we don't want the user to be able to initialize that. We're going to declare it in this area outside of all the methods, this code that's called every time an object of this type is created. We're going to create health and initialize it to the max health, whatever the caller gave us. So we want to say every player always starts at max health. So we'll initialize that outside of the constructor. For the ball and health potion classes, we're going to move all of that state to the constructor. We're going to let the caller initialize everything, all of the state of these variables. We're going to use ValorBar where appropriate. The mass, we don't expect that to change. We don't want to allow that to change. All the rest, actually dimension should probably be val as well. We don't expect the dimensions to change. Location and velocity will certainly change. Those have to be var. And we want these to be accessible from outside of the class, so ValorBar we're going to use. Very much the same with health potion. We're going to move all of its state to the constructor and let the caller decide what the state, at least the initial state of the health potion is going to be through that constructor call. And now that we're set up with classes, we can start using the keyword new to say, give me an object of this type, call the constructor, get some memory in heap space, ask the operating system for a chunk of the RAM stick, and start creating objects of these types on the heap, get the references to those, and then work with those references to the different objects so we can start working with multiple objects of these types in our game. All right. Any questions on the objects and classes review? Hopefully that cleared up some last misconceptions about objects and classes. But any questions on this before we move on to inheritance? Moving on to inheritance. So we see the same thing that we saw in the lecture question on Friday. Ball and health potion have a lot of common functionality, a lot of common state, and a lot of common behavior. Well, they don't have much behavior because not a lot can fit on the slides. But they have common state and common behavior. So let's refactor this and try to get that functionality out of here, out in a separate class. So what we would like to keep in mind, just don't like that slide. Anyway, what we want to do is factor out that common functionality and do this in a way that's going to make our game easier to expand. So we can get away with these two classes and start expanding this functionality and add functionality to both of these classes independently and have them behave as two completely separate types. But what happens when we want to add a lot of more common functionality? Are we going to duplicate all that code twice? And more importantly, what happens when we want to add 5 more types of items to our game? Well, if we want to add 5 more types of objects to our game, and we're pasting code 7 times every time we write it. That's what we don't want, and we're going to avoid that with inheritance. We're going to pull out all that common functionality, common state and behavior, and put it in a separate class called inanimate object, and then extend or inherit all of this functionality from inanimate object in our ball and health potion classes. And then in ball and health potion, we're only implementing the functionality that's different between the two and sharing everything that's in common through this inherited class. So this inanimate object class, we're going to store all of that common functionality. We're going to create the constructor with all of our physical properties, how to exist in our physical space and how to move around in it. And we're going to declare 2 methods, the use method that we saw in both classes, and I'm going to create a new object mass method. So maybe I want to know the mass of both of these. With the ball, it was just a mass variable. But with the health potion, I had some volume, and I could use that volume to compute some mass. So if I want to figure out, say, the momentum of 2 objects in this game world, of any object in this game world, I want to be able to compute that mass. I already have the velocity, and I can start computing these things. So I'm going to add an object mass method, but I'm not going to define these methods. These methods have no body, no definition. I'm just declaring them and saying, inanimate object has a method, it's called object mass, it takes no parameters and returns type double. It also has a method named use, it takes a player reference as a parameter and returns unit. But I didn't say what these methods do. Now these are what we call abstract methods. They're methods with no definitions. And when we have these, if we have any abstract methods or abstract state variables, we have to have what we call an abstract class. We have an abstract class at this point, which means this class is not fully defined. We cannot say new inanimate object. We'll get an error. It'll say this object, this class is not fully defined. We have some abstract methods in here. You can't create some with an abstract method. It's more of just a concept. It's an abstract thing that can't really exist on its own. So what we're going to do is extend this class through our other classes, in our other classes, bring back our other classes, our other types, and use the keyword extends to extend an inanimate object and inherit all of its properties, all of its state and all of its behavior. It's going to be part of our new class that extends it. Then we have this syntax for that extension. We still have our ball constructor. We're going to define that the similar way that we were before, except now in this extends, in this header, we're going to call the constructor of the inanimate object method. So we're going to call this constructor using some of the parameters of our extending class's constructor. And then this constructor is called an inanimate object at the same time that this constructor is called, and we can get that functionality. Now when we extend an inanimate object, we inherit these variables. These are all declared with var, so location, dimension, velocity are all inherited through this extends keyword. So we have those variables in this ball class, but we're also taking variables with those same names in the balls constructor. So we could have a naming conflict. If we put val or var in this constructor, we're going to get some issues because we have multiple variables with the same name in the same scope. They would both be accessed with this dot. So we can't have that. We're not going to have that. But in this constructor, we can just forward these, not use ValorBar here, not expose these anywhere, and just forward them to the other constructor to be able to pass those values along. Then we have to implement those methods. So in the inanimate object class, we left that as abstract. We had two abstract methods. We didn't define them. This is where we're going to define them. We actually have two options. We're either going to make ball also an abstract class and not define both of these, or define them so we can start instantiating, creating objects of this new type. We're going to implement them. We're going to use the keyword override for that. We're going to say, I inherited a method from one of my classes that I extended. I inherited some method, and I don't care what functionality is in that method. It happens to just be no functionality in this case, but we could have definitions in our abstract class too. I don't care what functionality that was, override that functionality with this new definition. So whatever object mass was, nothing in this case, override it with this definition. Same with use. Override whatever was the use method that I inherited, whatever definition it had, if it had any, override it with this functionality and do this instead when you call use on this thing. Since we implemented both of these methods, we don't have to have this class abstract. We can actually create objects of this type now, where we have a fully defined class at this point. We're going to do the same thing with the health potion class. We're going to extend inanimate object, call inanimate object's constructor. In here, we want to make volume accessible to the outside world, so we'll use val. Where with ball, we don't need to make mass accessible to the outside world because they can access it by calling object mass. When we implemented that, we made that accessible, so we don't have to use ValorBar there. That is the difference there. But we do need to know the volume, or not necessarily, but we might want to know the volume separate from the mass of a health potion. If we, say, have a player's inventory where we're concerned with volume, how much space does this thing take up? Maybe we want to have that accessible to the outside world. So there are different decisions based on what your application is, whether you use ValorBar or nothing in those cases. So now we have our two classes sharing this functionality. But why would we do this? So right here, there's a strong argument to say, why did we do this? Because we just added a lot more code. We wrote a lot more characters to get to the same place we were, and we have 3 files instead of 2. It looks like all we did was add complexity to our program. And I concede to that one. I'd say, yeah, for this simple of an application, why would you bother with OOP? But the question becomes, what happens when you want to start expanding your functionality? What happens when your methods get more complex, more complicated? Say we want to add momentum to our game. We want to have some objects colliding in complex ways, or we want to take that momentum into account when a ball hits another player and take that into account for the damage calculations instead of just the mass. What if we want to get more complicated like that? Okay, we can write the momentum method, but would you write this twice in once in health potion and once in ball? Cut and paste that code, and it's got to be a little different because their mass calculations are a little different. Or in this case, we can just call the object mass method, which is going to have different functionality based on whether this is a ball or a health potion, based on which method we used in the override, and then have all this math here. Now, this is a lot nicer when things start to scale up. We write this code once in an inanimate object, and our 2 other classes get that behavior. They now inherit this method, and I can call this method from my other 2 types. You can imagine these methods getting more complex. What if I have a method with 100 lines of code? I'm going to write it once in an inanimate object, and then anything that extends an inanimate object gets that method through the inheritance. And what happens when I have that 100-line method? Maybe I'm not using inheritance, and I have 5 more object types. We have those 7 types in our game. We're cutting and pasting 100 lines of code in each of these 7 files, and then we want to make a change to that 100-line method. We want to make a little change the behavior a little bit. Now we got to go to these 7 files. Now we got to test these 7 things independently again. can be a real pain just asking for bugs and headaches. In an inanimate object, we write that method once, we update it once, and all 7 classes are automatically updated. We just have to make one change in one class and change the behavior of every inanimate object in our game. Even if we're scaling up to like hundreds of different types of inanimate objects, it's no big deal. You change it once in the base class, done. Yeah, and many, many, many subtypes. I got ahead of my slide there. It happens. We can do even more here. Now, if we have those 100 objects that all, well, let's stick with 7, 7 objects that all inherit inanimate object, and we want physics to work in our game. We have our physics engine, it's working, we're happy with it, but our physics engine works with dynamic objects, and it doesn't work with these inanimate objects. Well, we'll go to inanimate object, and just extend dynamic object, call the dynamic object constructor, and then overwrite this, set the value of this velocity. Now everything that is an inanimate object is also going to work with our dynamic objects in our physics engine. We throw these dynamic objects, balls, health potions, and whatever else we come up with, throw those in the dynamic objects list in our world class, or object, in the physics engine, and now these things move through the space, gravity is applied to them, they collide with static objects, and if you do the extension objective, they'll collide with other dynamic objects, and we have all of that physics available to us by extending this class without having to care about that when we write the physics engine. When you do your physics engine assignment, you never know what a health potion is, you don't care, but if a health potion ends up extending dynamic object, your physics engine applies to those health potions. Just like the jumper code, the players, the platforms, the walls, none of those things show up in your physics engine assignment at all, but those things work because they extend dynamic object and static object to be able to work with your physics engine. And I just want to point out this, this line here. When we extend dynamic object has location, dimension, and velocity defined within it, and accessible to the outside world using ValorBar for location and dimension anyway, and velocity defined separately. So we already inherit a variable named velocity, and we can access it with this dot velocity. Now before we used to have, and we removed the val and vars from our location and dimension because they're already defined and declared in dynamic object. But with this dot velocity that's defined in, inherited from dynamic object, if we kept this input named velocity, we would have a naming conflict here. We would have 2 variables, and we would access both of them using this dot velocity. So if we say this dot velocity, or if we say just velocity, how do we know which velocity we're referring to? There are ways to do this, but it's a little more than we want to do right now. For now, or forever really, is probably the best thing to do anyway, is just name this something else so we don't have that naming conflict. So we can say this dot velocity, very clearly meaning the velocity variable that we inherited from dynamic object. Set that equal to whatever I got from my input parameter. So for the lecture question, you're going to have electronic, abstract class electronic that defines a variable named battery, and you're going to inherit that battery variable in your other 2 classes. Then you're going to have a boombox, which is going to take a battery in its constructor. That battery in the constructor can't be called battery because then you're going to have that naming conflict. So name that something else so you can do something similar. This dot battery equals my battery for my constructor, so you can avoid that conflict. And now our inheritance trees make more sense. We have dynamic object, which was extended by inanimate object, which was extended by 2 other classes. And we can have our inheritance trees from this, which is what this is. We have this class any, and absolutely every class in Scala extends any at some point. That's the root of every inheritance in Scala. There are 2 main classes after that. Any val extends any, and is extended by these values, which all go on the stack. And for our purposes, for now at least, we can assume You can pretend strings go on the stack as well, though they're not in here. We'll talk more about that when we get to immutability. And then any ref, which is anything that goes on the heap, including our classes. If you create a class and you don't explicitly extend anything, you implicitly extend any ref as your extension. That's where you get some methods like toString and dot equals, which is called through equal equal. You get that functionality even though you didn't implement it because it extends any ref. Bring us back to lecture question. With that, see everyone Wednesday.